Hello everyone, welcome to my YouTube channel Easy Programming. I'm Naveen Mishra. Let's get started with today's video tutorial with today's topic, that is threads lifecycle, methods and priorities. In my previous video I have started and told you some theoretical information about the threads. So let's have a quick revision and then we'll start with the program. So what was thread? These are individual programs, these are individual modules that can work independently with other threads, right? These are the lightweight processes, the smallest unit of processing, okay? So the main advantage of having a thread is that they can run simultaneously with other threads and their execution can be left in between and can be continued later by the CPU. To make a thread in Java programming, we have two ways. Either we can use a thread class or we can use a runnable interface. Then after the thread, the topic is multi-threading. When more than one threads execute at the same time, then it's called multi-threading. Okay, so we have covered this in the video. Now what was multi-threading? Multi-threading looks like this thing. So let's say we have three threads, 1 2 3, and we have a main thread will call these threads, and then these threads can switch in between in their execution. That is, thread 1 can execute some code, then stop, then thread 2 can execute some code and then stop, then again thread 3, then again goes back to thread 1, thread 2, thread 3 until all the threads complete our execution. So let's have a program of this. Let me start the NetBeans. Okay, so let's start a new project. Okay, Java application it is, and I'll say threads. Okay, so let's place some classes inside this. So here I'll go inside the source package. I will create a new class. I'll say A class, simple class A. And to make it a thread, I'll inherit that inbuilt thread class. Okay, and then I will have a run method. Every thread class must have a run method, and I'll write the code here. System dot, just a second, sorry. System dot out dot println inside the thread A. I'll start a loop here. I equals to 0, I less than 5. Then value of I equals plus I keys, and at the end of the loop I'll say system.out.println end of thread. Okay, so this is a simple thread. I'm not doing much, I'm just testing how the thread works. To remove this error I have to declare a variable as well. Okay, so that's it. I have a class A thread. To implement the multi-threading, I have to create 3 threads. So I'll create another class. The name will be B. Finish. I'll create another class, that is right click thread, Java class, and I'll say C thread. Okay. And what I'll do is I'll copy paste this code and replace it with J. Here I'll say extends thread. Instead of I, I'll say J. Method will not change because this is an abstract method defined in this thread class. Okay, so here I'll say instead of I, I'll say J. Value of I, no value of J. Here's J, and here I'll say thread B. Then I'll go back to this code. I have to save this. Okay, then I'll paste the code here. Here I'll say extends. Instead of C, I'll say K. I'll say C, and here that's it. I have created three threads. So just like this pictorial representation, I have created three threads ABC. I have written the code here. Now I'll link it inside the main thread. So let's do this. What I have to do here is I will create the object of these classes. So I'll say a space a1 equals to new a, b space b1 equals to new b. Here a1 and b1 are the objects of the classes. I'll give you a message. Start of main thread. Then to start these threads, I have to call the start method. So I'll say a1.start, b1.start, or c1. And at the end, I'll say okay. Here I have to correct this. So I think it should work. Simple program of multi-threading. I have three threads ABC. I'm joining it inside the main thread class. So let's play and run this value. Okay, so there you go. You see the output. You see there start of main thread, and suddenly you see the message end of main thread. Actually what is happening is there are four threads. One is main thread, then A, B, C are the three threads. Now processor is executing these threads based on the availability and time. So first of all it started the main thread, then completed it, then started the A thread, then completed it, then started the B thread, then in between it stopped and started thread C. It finished thread C, then goes back to thread B and executes it. If you try to run this program again, next time your output will totally change. Okay, you see there now start of thread, end of main thread, A executes A, B executes B, C executes C, and A thread is finished at the end. Again you run and you will have the different results. This is because it's all about the availability of the processors. So in multi-threading, the output of the programs are not as per the pattern. It is based on the processor's capability or the processor's availability, that how these threads will be executed. So this is a simple program of multi-threading. Now here I can save my time by simply saying let me do that just a second. I can say new a dot start. Let me see if it works. Yes, it will work. So straight away you can call the new method and you can call these methods as well. Let's try the program. There you go, your program still works perfectly. So what I'm trying to tell you here is you don't have to create the object independently. You can just call the new operator followed by the constructor name, and then you can call the start method. So it's a simple program of multi-threading. So let's move on. We have done that. Okay, now there's an important topic of thread, that is the life cycle of thread. Just like a human life cycle, where a human life cycle goes through various stages like born, childhood, young age, adult age, death. Okay, or this is my perspective of human life cycle. You can add more phases in it. So what I'm trying to tell you here is that humans go through a life cycle. Similar to that, threads also go through a life cycle. There are various stages, there are various states through which a thread goes by and ends normally. Okay, so let's study about this life cycle. So life cycle of a thread is a sequence of methods or sequence of states through which a thread goes in during his whole lifetime, his or her, whatever you can say, during its lifetime. Okay, now there you go, we have a life cycle of thread. So first of all, you have a newborn state. Generally we have 5 states. The one is newborn state, second running state, third runnable state, fourth blocked state, and fifth the dead state. Okay, so whenever you create a thread, what I'm trying to tell you here is, just a second, sorry, what I'm trying to tell you here, whenever we write this line like this, a space a1 equals to new a, or we'll say new a dot start, whenever we say this or before this line, or this line, you have a newborn state here. This is a newborn state. Okay, so once your thread is born, you can call this start method. You see, this is the start method. So when you do this start method, your thread is ready to execute and enters in a state of active threads. Okay, now let's say this is the program, these are the programs which a processor is looking to execute. Okay, now there is only single processor or a single CPU. It cannot execute all of them at once. It will pick one at a time. So it will pick P1, start it, execute it, then goes back to P2, then execute it, then goes back to P3, then execute it. So it started with P1, then followed by P2, and then followed by P3. When it was executing P1, P2, P3 were in waiting state. It is not exactly waiting. They are ready to execute, but they are waiting for the availability of the CPU. So they are called in runnable state. So runnable state right now will be for P2 and P3 because they are ready to execute, but the availability of CPU is not yet available for them. At that time, P1 is running. After some time, either P1 finishes or P1 is stopped in between. Then P1 enters in the state of runnable state and P2 enters here. P2 starts executing. Then again, after some time, P2 is placed back in this list, and then next time P3 is executed. Okay, so this is how the threads, active threads, are switched from running state to runnable state. Okay, during this switching, you can use a yield method to pass your turn, to pass the execution turn of one thread to another thread. Okay, so these are the active threads and how these threads are working. Now the running threads can be stopped in between for a particular period of time. Then they enter in this blocked state. In this blocked state, the thread is not executing, it is not taking any CPU time. Okay, to move our active threads from the list of active threads to the blocked state, you have three methods: suspend, sleep, and wait. Simply saying suspended because it is waiting for something to happen, or the CPU is switched to some other process, so it enters. You can call the suspend method. Sleep is for given milliseconds. In sleep method, you give some time. Time is given in milliseconds. Once this time is over, the thread start executing or enters in the active threads automatically. So from active threads to blocked thread, if you are using the sleep method, that is, you are stopping your program for a given milliseconds. Okay, and then there is a wait method. For example, a processor is being executing, or a thread is being executed, and it needs something like IO device which is not yet available. Then this thread enters in the blocked state, and once these resources, that is IO input output statuses, are available, then it is moved from blocked state to back to this active threads. Okay, so these are three methods using which you can move your active threads to your blocked state, and from the blocked state you can move them back to this active states using these methods. So resume, notify, and notify all. So if your thread is stopped using the suspend method, then using notify and notify all method, they can enter back in the active threads list. And if you have using the wait method, then resume method will be called to resume the things. Sorry, I think I'm telling you wrong here. Just a second. For suspend you need resume to activate, and for wait, notify and notify all. For sleep you need given time in milliseconds, and then you can go on with that. Now the running threads can be stopped in between, that is, their execution is stopped forever and it will not continue again. This is done using the stop method. So once you call these stop methods, your thread enters in this dead state. From this dead state, there is no way of coming back in these lists. A thread which is dead cannot come back in these states. Okay, so you can call the stop method. Using stop method you can move the thread to the dead state, or a thread after completing its execution comes back normally into this dead state. Okay, so this is the life cycle I have explained. Now let's go with these theoretically. Okay, so newborn state. When we create the instance of the thread class, we enter in the newborn state. I have told you earlier. Now runnable state. Once the start method hits, it starts executing, you move on to the running state. you are waiting for the availability of the processor. The running state, from runnable to running state, the thread comes and goes, that is, it switches from one state to another thread, another state, and you can call the yield method. What does an yield method do? Yield method is used to cause the currently executing thread object to stop temporarily and allow other threads to execute, okay, to switch the turn. Now blocked or waiting states, so at that time your thread is temporarily inactive, it is blocked, it is not doing anything, okay. Now these are the methods to block. So wait state, current thread to wait until another thread calls the notify or notify all methods. Sleep for a given milliseconds and suspend the thread. You are waiting for a particular event to happen. When this event happens, only then you will start resuming your code. And dead state, the thread can enter in the thread state in two ways, either finishing the execution normally or doing the some erroneous event occurred, okay. So these are stages when your thread moves to the dead state, okay, or you can call the stop method, okay. So let's try to implement these in your threads. So I'll start with the sleep time. So I'll say if I equals to 3, then I'll say stop, and else, okay. Now this strike through simply means that this method is no longer being used. This is because it is currently not in practice, okay. Yeah, or generally you don't do this. It is not an error, your program will work, okay. So let's try this, let's see what happens now, okay. So you see here your thread A executes for 0, 1, 2 only. After 3 it stops, it is not working, you see here, okay. So when your I hits to 3, sorry, when your I hits to 3, the stop method stops the execution of your thread, okay. So this is an example of stop. Okay, let's try the sleep now. For sleep you have to put the code inside the try catch, okay. So just a second, if j equals to 1, sleep for 1000 milliseconds, okay. Okay, so it might raise an exception, interrupted exception, so I have to put it inside a try catch block. Just a second, try, and I'll put this code here and followed by catch, interrupted exception. I'll just write a error message here. Okay, so let's try if it sleeps for 1 milliseconds. Now this 1000 milliseconds is equals to 1 second, so your B thread will stop for 1 second. Let's see. Okay, let's try to run one more time. You see here it stops and then this output J comes. Let's see there again, there you go. This is because your stop method is working, okay. So this is your stop method. Sleep method, so sleep is there, start is there, and stop is there. So I think we have implemented most of these multi life cycle of thread methods, okay. Due to the shortage of time I'll not be able to implement all these methods, so I'll stop this here and let's continue forward, okay. So let's start with the new is alive and join methods. Now independent of the life cycle you have two more methods, that is alive and join. These are the two ways to know whether your thread is finished executing or not. So let's start with is alive. This method returns true if the thread upon which it is called is still running, it returns false otherwise. So simply if you want to check that if your thread is working or not, if you want to check that your thread is not dead, you can call this is alive method. And similarly a join method. A join method is generally better equipped or better to use because it waits for that thread to terminate and then call the join method. So let's see if we can implement these methods. I'll go at this main thread and I'll try to call. Okay, I have to use the objects for this now. Say a1 dot join, and in between I can check. I'll check a1 dot join here, and I can check b1 dot join here. Let me see what kind of error there. So again they can raise an exception, so I have to put them inside the try catch block. Okay, so I'll put everything inside the try catch, and I'll end it here. Followed by the catch, interrupted exception. I'll just do error message. Exception raised plus IE dot get message. Okay, I think it should work now. Let's see. I have to okay, let's see what is the output. Okay, can we see anything in between here? No. Okay, I have to put it inside the this. So if a1 dot join returns true, then I'll say okay, cannot be converted to boolean. Okay, so I'll say equals to true. Will it work? No, it is not working. Okay, just a second. Do that. I'll add one more thing. I'll check for c1 here. C1 dot, I'll use the isAlive method. So I'll say system dot out dot println thread c is alive. For this I'll say plus c1 dot is alive. Okay, so let's see what happens now. Okay, this curly braces should be placed here, and let's see if it works now. Okay, so there you go, it is giving you result in true or false. Thread C is alive. False, because thread C has finished executing here. Okay, so let's try one more time. End of thread C, so it falls again. Thread C is alive, false. Okay, so let's try to implement this on. Let's see what it says. So again, thread B is not alive, so it's just giving you the status that whether your thread is alive or not. Okay, so this is alive and join are being used here. Okay, so let's move on. Thread exceptions. Now you guys know about the exception handling. Generally, when you're working with threads, two kind of exceptions can be raised by your thread class. One is interrupted exception that I have already shown you here, that we are using try catch and placing our code inside this try catch, and the catch is having this interrupted exception. The interrupted exception is used generally for sleep method or any kind of interrupted exception. This would happen if some other thread wanted to interrupt this sleeping one. So the currently stopped thread cannot be initiated to do some kind of work. So in such case, you can use this interrupted exceptions. And then you have this illegal thread state exception, that your requested operation is not compatible with current thread state. So what I'm trying to tell you is, let's say you have stopped your thread and then you're trying to check is alive or is joined. It will not work. Okay. So these are the two exceptions raised by the thread classes. Okay. Now priorities of thread. Now let's say we have these three threads running, 1, 2 and 3. Okay, now these three threads are running. Thread 1, thread 2, thread 3 are given the equal priority. So if 5 seconds are given to thread 1, the 5 seconds will be given to thread 2, 5 seconds will be given to thread 3. So there is no priority right now in your threads, but sometimes you may need thread 1 to execute more than thread 2 or thread 3 because your thread 1 is more important or your thread 3 is lesser important, so it should execute less. Now there is a way that you can do so by implementing the concept of priorities. So generally higher priority threads get more CPU time, but you can use this set priority and get priority methods to set the priority or get the priority of your threads. Now set priority method must pass an argument. This argument can be a value in between 1 to 10, 1 being the lowest priority, the minimum priority, and 10 being the highest priority, the maximum priority. And by default all your threads is given a priority number 5, which is a normal priority, norm underscore priority. Now these capitals, these words written in capital represents these are the constant variables like min underscore priority, max underscore priority, or norm underscore priority. So I'll try to change the priority of some thread. So let's try to do that. So here I'll say system. Okay, at the beginning I'll try to do that. System.out.println the priority of thread A is, so I'll check it using the plus a1 dot get priority, and I'll set the priority of the thread like this. C1 dot set priority, C1 dot get priority plus 2. So the priority of C1 will be incremented by 2, or I can say B1 dot set priority max underscore. I think I have to use the thread class first. Variable max underscore priority. Is there a spelling mistake here? Yeah, there was a spelling mistake. So let's try to do this, and I'll call the set the priority, get the priority as well of these threads. So I'll say here B1, here I'll say C1, priority of C, priority of B. Let's try to run this. Okay, so this is your output. Let's see. Now the priority of thread A is 5, the priority of thread C is 10, B is 5. It didn't work. Let me check why. C1 priority. Okay, I have printed the. Okay, let me do this C1 and C. So it should be 7 now. 5 plus 2 equals to 7. Let me check that. There you go. The thread priority is 7. So we can increase or decrease the priority of threads using this set priority method. We can come to know about the priority of a thread using this get priority method. So that's it from today's video. Thank you very much for watching this video. Please do subscribe and share to my channel. Thank you very much. See you in the next video. Cheers.